going to teach you रियल नंबर्स। रियल नंबर्स से पहले हम कुछ समझने की कोशिश करेंगे कि नंबर्स हमारे पास होते क्या हैं और कौन कौन से नंबर हम जानते हैं। जैसे नेचुरल नंबर्स हुआ, होल नंबर्स, these are we know already as natural numbers. Natural number denoted by n. Natural numbers. Natural numbers, as we know, natural numbers. Counting numbers are called natural numbers. Counting numbers are called natural numbers. As 1, 2, 3, 4, 5, 6 up to infinite. नेचुरल नंबर स्टार्टेड फ्रॉम वन। ये एक से शुरू होते हैं क्योंकि हमारी नेचर ने जब भी शुरुआत की है तो एक से की। पहले कोई प्लांट बनाया तो एक, कोई क्रिएचर बनाया तो एक, ऐसे। बिकॉज इट्स नॉट स्टार्टेड फ्रॉम जीरो। बट व्हेन वी हैव यूज्ड द नेचुरल नंबर्स, जब भी हमने नेचुरल नंबर का प्रयोग किया है तो इनसे एक सीमित एरिया दायरा बना हमारा कि हम जीरो से एक से लेकर के नाइन तक ही लिख सकते। जैसे हम नेचुरल नंबर से देखते हैं कि हमारे पास डिजिट तो सीमित है एक से लेकर के नौ तक की, तो इनसे हम संख्याएं बना सकते हैं बहुत बड़ी, लेकिन बहुत ज्यादा नहीं। कुछ कमी सी महसूस हो रही थी कि और कुछ इसमें ऐड होना है। जैसे ही हमने ऐड कर दिया है जीरो को मिलाया तो ये नंबर्स हो गए होल नंबर्स। इससे जितना बड़ा चाहे, जितना एक्सटेंड करना चाहे, जितने से भी ज्यादा जिस वो भी हमारे नंबर पास लिखना है वो हम लिख सकते हैं। तो होल नंबर्स, इससे हो गया कि संख्याओं को पूर्ण रूप से हम जितना एक्सप्लेन करना चाहते हैं लिख सकते हैं। Therefore, it is called a whole number. Whole number started from zero as 0, 1, 2, 3, 4, 5, 6 up to infinite. अनंत तक हम इनको लिख सकते हैं। We can define it real or natural numbers be called whole numbers. Now we have defined the whole numbers. We know also whole numbers started from zero up to infinite. But now we are going to define the rational number or integers. 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 Integers means whole number, whole number, whole numbers plus natural numbers, whole numbers plus natural numbers are called integers. Integers. As we show number line also this. If it is 0 here, then it is -1, -2, -3, -4 or up to infinite. If then from 0 if we move right side, then it is positive. If we move to the left side, then these numbers are negative. Negative numbers. Then write here 1, 2, 3, 4, up to infinite, limitless. These are integers. Here we have shown the natural numbers also, whole numbers also, and negative numbers also. Now we are going to define the real numbers or rational numbers. I know now natural numbers, whole numbers, integers. After that we are going to define the rational numbers. We are going to define the rational numbers. Rational numbers means if we can in the form of, if we can write in the form of p by q, or as a fraction we have studied in lower classes. We already from third, fourth, fifth in these classes we have studied like a fraction, but there is not, it never said to us these are rational numbers, but now we can define that by the next number, other number, rational numbers, or we can define it as rational number if we are able to write in the form, write in the form of P by Q। अगर हम इसको P by Q के रूप में लिख सकते हैं और यहाँ पर हमारा डिनोमिनेटर Q जीरो नहीं है, then it is called a rational number. Then it is called a rational number। परिमेय संख्या जिसको कहते हैं रेशनल नंबर। But there is a condition also, there should not be any factor common in P and Q, where P is numerator and Q is denominator। जहाँ P अंश है और Q हर है और Q जीरो ना हो और जिनमें कोई भी गुणनखंड कॉमन भी ना हो, तब इसको स्टैंडर्ड रेशनल फॉर्म कहते हैं। एज एग्जांपल्स आर दिस examples we can write, first we write all the rational numbers, after that we write the some standard rational numbers as 1, 0 also rational number, 1 by 2, 3 by 4, 8 by 16, 20 by 25, these are all are rational numbers, but we want to write the standard rational numbers, standard rational numbers, standard rational numbers, rational numbers like 1 by 2, 3 by 4, as 1 by 9 also, 9 by 11 also. There is not any factor common, or simply we can say the CF of numerator and denominator is 1. If a CF is 1, then it is called standard rational numbers. Then we say the positive rational numbers, positive rational numbers, positive rational number. Positive means the resulting sign should be in the denominator for positive, as 1 by minus 1 by 1 by minus 2. It is also positive, or if it is written here 1 by 2, 3 by 4, there, or we can say denominator should be positive. डिनोमिनेटर पॉजिटिव है तो ये स्टैंडर्ड फॉर्म में है, अगर डिनोमिनेटर नेगेटिव है तो ये स्टैंडर्ड फॉर्म में नहीं। Going to define the real number, it is like a bag. If a bag we have and I have filled all the numbers in this bag, then all those numbers are called the real numbers without imaginary number. We have studied in these up to high school or then these classes only real numbers, not imaginary number. Imaginary numbers we start from intermediate. So all these numbers which we know up to high school, all numbers we are called the real numbers. As we know, as natural numbers, whole numbers, integers, rational numbers, these are prime numbers, composite numbers. If we put all together, then we make a set of real numbers. These are real numbers, so we define set of set of all numbers are called real numbers. As 0, 1, 2, 3 up to infinite, -1, -2, -3, -4. In these we can write here 1 by 2 also here, 1 and 1 by 2 also. So many infractions are, these are called, it is a set of real number. So we have defined here the rational number, real numbers. Then we are going to represent on number line. These are real numbers, so we can represent on number line. So I want to represent the real numbers as on number line. As under root 3, under root 3, under root 3 we want to so on number line, number line. We know, as we are saying, it is very difficult to show number line, but it is so simple. As we know the Pythagoras system, Pythagoras theorem, so this way we can, with the help of that theorem, we represent the irrational numbers also on number line. Rational numbers we have shown. This is the number line. We have represented the real numbers on number line. Real numbers are two types also, rational and irrational. Rational and irrational. Rational we have represented on number line, but I am going to represent the irrational numbers on rational numbers. Irrational, irrational numbers, irrational numbers on number line. See here we can write this number in this form: 3 equal to 3, 2 plus 3, or we can write it also 3 into 1. 3 into 1. Now working pattern is this. Now we add here, draw a line AB as 3 plus 1 equal to 4 unit. Unit means as you want to, in centimeter, in inches, in other also. And so first we draw the line of 4. We have taken here as in centimeter. So draw the 4 centimeters line. First we draw a line AB of 4 centimeter and mark from right to left. It is 1 centimeter. It is a point my let it is O. Then bisect the line AB, bisect the line AB, and it is the center of AB, and we take the radius as AC and C as a center, then draw the semicircle on this. Then we draw the semicircle, then we come to the point O and draw here a perpendicular or make the angle of 90 degree with the help of compass. Then and we draw the perpendicular at point O. This this line which touch to the circumference, this is called the under root 3 line, because it is this hole is 4 centimeter and half of 4 is 2, so it is also 1 centimeter. It is also 1 centimeter. So here to here it be 1. Here to here also it be 1. Then line ON, O to N. It is called a line of, it be make, not called also. It is the line of under root 3. Or we can write namely ON equal to under root 3 unit. Or we can see 3 unit. Or we can say here, find the square root of any irrational number by the geometrically. So on number lines. So how we show on number line? Then we extend the line OB to the side O to B and mark also here numbers 2, 3, 4. Then we with the help of compass measure the ON and draw in all up to 9. Then let it, we can let it out. It is this way. Then under root 3. Under root 3 means it will be this way. Then or we can draw it dotted also, because we have not here a compass. We use the compass here and draw the line on the, now this will have on the number line. We have represented ON on the number line as OP. We can say OP equal to ON equal to under root 3 unit. This way we can represent any irrational number on number line. Number to represent on number line as it is under root 7. We can tell you two examples. One and another. One we have explained, we are explaining just as we have done. And we write 7 equal to 7 into 1. Now we let its line be AB, then 7 plus 1 equal to 8 unit, 8 unit. So we draw a line. First we draw a line with the help of scale and pencil. It should be a straight line and mark it as it is 8 unit. 8 unit. What is its length? 8 unit. So 8 units we can write also as then we it is AB, name it AB from here to here. Then we bisect it with the help of compass, not this way. With the help of take more than half, then arc both sides up and down where they intersect. Then we join these. It is the center of this line. It is bisected. It is AB. Now we draw the semicircle as AC be the radius and C is the center. C center होगा और AC त्रिज्या होगी. इस त्रिज्या को लेकर के हम एक सेमी सर्कल बना देंगे. Ardhavrat. Semicircle means ardhavrat. Now we mark at the one here. Then we make the angle of 90 degree at point O. Make the angle of 90 degree at point O. It comes to the circumference. Then measure the ON. That be the under root 7. What is the process? First we draw the AB line segment 8 unit because 7 into 1, 7 plus 1 equal to 8. Then mark at 1 unit here, here to here. Bisect it, take its radius AC and draw the semicircle at point 2. Make the angle of 90 degree or draw perpendicular which touch to the circumference at N. Then ON be the under root 7. We want to represent on number line. Then we exceed it to the right side. Then we with the help of compass take it take it on as a radius. Then bring to the number line as dotted. This way it be more than 4. Then it is the ON equal to OP equal to under root 7. This is the method to represent the numbers on number line. Now we explain this number by. If we want to show on number line, then find the value of under root 7 geometrically. Then this will be solved by another method. As 9 we can write in the form of 16 minus 9. It is also 7. Now we can represent it as it is square of 4. It is square of 3. This way we can find its value on geometrically also. Now as we know the Pythagoras theorem, in the Pythagoras theorem, it is a right angle triangle, it is the hypotenuse, it is the base, it is the perpendicular, and it is of 90 degrees. Now we can write it in the form of as a formula as given by the Pythagoras. H square equal to perpendicular square plus base square. Now, if we subtracting here, then we write it at s square minus base square equal to t square. Now we are subtracting here, so 4b hypotenuse and 3b base. So we draw the base of 3 unit, as 3 unit we have drawn here, and make here a perpendicular with the help of compass, and from it is AB, from A as a center with the radius of 4 unit, we have arc here and joint it where it intersect to the perpendicular. अब जहाँ पर ये परपेंडिकुलर को कट करती है वहाँ पर ज्वाइन कर दिया है इसको. अब यहाँ से now it be C. Now BC be the under root 7. If we want to represent on number line also, then we can represent on number line also. We have find the value of under root 7 by geometrical method. If we measure BC, then BC equal to be the value of under root 7. We want to represent it on the number line. Let here be 0 and here are numbers 1, 2, 3. Then with the help of compass, we take it, measure it, and it is as a radius, B as a center, then we show on number line. And if we want to it draw, if we take it dotted, then it will be better if we know, because we show what we have done and which point at which point it touches to the number line. Then it is the BP equal to under root 7 and on number line. Have you understood? Now other important terms I will explain in the next video on number line. Thanks.